After our inclusion of our dummy variable, then we see that our R squared number has improved. We use the 5 steps of strategic decision making that we saw in step 1 to look at information. So we have this example from Harrah's Casino and regression analysis. So first, what is the issue or the problem? So Harrah's strategy is based on customer service and customer loyalty. Alternative actions, dealing with customer pain points or the amount of loss when they leave the casino. They want to obtain information and conduct analysis of the alternatives. They're going to use regression analysis to predict when each customer may reach the pain point. They use this prediction model to intervene when a customer is reaching the pain point. And then they provide ongoing evaluation of the effectiveness of the implementation in step 4. We also have time series and cross-sectional regression analysis. So time series regression is the most common type of regression analysis in our cost management. This is where we use previous information or historical information to predict future information. Cross-sectional regression is used to predict costs for a given cost object based on costs of related cost objects. So we have information here of cross-sectional regression and time series regression. So we have 3 years of information that we are using to predict the next year's cost. Then we're also using information for departments 1 through 4 to predict department 5's cost. Some implementation issues with cost estimation. We have 3 main issues: trend and seasonality, outliers, and data shift. So trend and seasonality. We often have seasonal trends. This means that our cost estimation is not linear. So the solution is to transform our variables, use a trend variable, or include a dummy variable. We also have outliers. That's when a data point or points are far away from the others, or data is nonlinear. Or a data shift. This could be the result of an unusual business condition that causes a shift to the data, something like COVID-19. This can also be fixed with a dummy variable. The next thing that we're going to talk about in Chapter 8 is learning curve analysis. So learning curve analysis applies when we have repetition of the same activity or operation. And the learning curve analysis theory believes that the more we repeat an activity, the better we get at it. So over time, we become more efficient, and then we can do the task more quickly with a higher level of quality. So cost whose amount is influenced by learning is an example of nonlinear cost behavior. When we're doing learning curve analysis, we will have a learning rate. So this is obtained through historical data. So the percentage by which average time or total time falls from previous levels as output doubles. A learning rate ranges from 1, no learning, to 0.5, our best possible outcome. When we're looking at the learning rate, we have this general equation used in learning curve analysis. Y is the cumulative average time per unit of output. A is the time required for the first unit of output, X is cumulative output, and B is the learning index. Y divided by A is our learning rate. When we're looking at learning curve analysis, this is useful in life cycle planning, CVP analysis, budgeting our production levels and labor needs, any make or buy decisions, capital budgeting, etc. How this helps us is it helps predict our workflows, especially our production level. So if we believe that every time a task is repeated, we learn how to do it better, which makes us faster, improves the amount that we can produce in a given 8-hour shift, then the more learning that we have occurring, the higher our production levels with that same crew. Some of the limitations of learning curve analysis. Learning curve analysis assumes that there's a constant rate of learning. It also only works with extremely repetitive tasks. So as we have anything that's a specialty, that doesn't work. Learning curve analysis doesn't work for specialty items. We need very repetitive tasks and repetitive operations. And our learning curve might be unreliable because this observed change in productivity in the data used to fit the model could have actually been associated with factors other than learning, meaning that our results weren't a cause of the learning or only the learning. That is the end of chapter 8.